Sure, guys.
Yep.
Okay, so first off, let's just find out who you guys are. Because architects, engineers, how about architects? Any architects? Okay, a couple architects, engineers. What do I got missing? Landscape architects? Not a chance. I knew it. Okay, so I can tell you all kinds of things and you won't be able to check me. All right, so I'd like to introduce Yi. I was sort of slated to do this presentation, and over time Yi has been taking over a lot more of these speaking engagements. So I said, you know what, let's have some fun here, and we're just going to keep sort of parlaying back and forth. Yi will talk about some of the technical elements, and I'll be basically telling you stories. So we'll start with the initial story, which is green roofs. The sky's the limit. So the reason I put that in there is because in the architectural community right now, green roofs are sexy stuff. I mean, they are they're being proposed on buildings all over North America now. There's a lot of visual impact to a green roof to sort of demonstrate an environmental agenda for either the ownership or a governing body or a designer. It really is a visual way of establishing your credentials, so to speak. So I want to take just a little bit of time to walk you through a couple projects that demonstrate what's happened with green roofs in the last 20 years. So green roofs are fairly new to North America in comparison to Europe, for example. And I'm talking about the modern green roofs. So we're not talking about sod roofs in Iceland, that sort of green roof. We're talking about the modern green roof where you're covering extensive roof areas with vegetation for perceived benefits from it. So this was one of the early projects. I just realized the laser doesn't work on a screen like this, so I'll have to point. So this was one of the earlier really major green roof statements in North America. It's the Ford plant in Dearborn. It was, I believe, a brownfield site, and the chairman of the board at the time, Bill Ford Jr., he basically wanted to say, hey, we're gonna do something radically different with this plant. So everybody thinks about manufacturing and they think, oh, it's bad for the environment, bad for this, bad for that. There's all sorts of horrible things that come from manufacturing operations. Well, Bill was going to change that perception, and he did that in a big way with this Dearborn plant. So what we have here is a whole blend of different technologies, and the most common thing of, or I guess example of a green roof would be these two areas here. They would sort of be an example of the extensive thin systems that are very prevalent in Europe that have sort of really become the most common type of green roof. But he also has added all kinds of other technologies, low impact development technologies like bioswales and even an orchard on site. So there's all kinds of different technologies integrated into this whole green roof proposal. The GAP headquarters, this is in San Bruno, California. Again, it's a William McDonough design. If you know William McDonough, he's really known for some of his out there designs, his sort of forward-thinking ecological designs. And they propose this sort of undulating roof. One of the reasons is to sort of reduce the noise, so that the shape of the building was very important to reduce the noise from the highway that runs fairly close by. They put a green roof on, once again, just not really for any big performance parameter, just more a demonstration of an environmental agenda. At this point, we're still in early days in North America. We're still figuring out what we can do with green roofs. So what they figured out from this is that by putting this green roof on, not only did that undulating roof help, but once this native meadow grew up to about 2.5–3 feet tall, it almost eliminated the noise inside the building. So they really learned something from that was actually more of an accidental education. The California Academy of Sciences, it's a Renzo Piano design. Here's a sort of top-down look at it. Again, It's the Academy of Sciences, so they want to demonstrate something about what the building is. And right here, I was up there at a conference a few years ago. They put a viewing deck so you can go up there and actually be a part of the green roof, stand in the middle of all this native vegetation. And what was interesting about it is they also produced a design that would encourage certain endangered species of butterfly to find a habitat here. Now, I don't know that they spent the millions of dollars it took to put that green roof on for the butterfly, but on the other hand, it was another added benefit. This is an inner courtyard at a hospital close by where I live, and I thought it was just kind of interesting. It's a great story. There's been lots of play lately about how vegetated areas, landscapes, have a real wellness component to them. People heal faster, they feel better in a hospital environment. So this isn't a cancer center. This is an enclosed courtyard. And what I found extremely interesting is I was there sort of right around the time that that courtyard opened. And people just came out kind of like, oh, wow. You know, sat on the benches, enjoyed the environment. So in that way, if I had enough time, and I don't, I could show you probably 300 slides of hospitals all over North America that are now looking at green roof living spaces as an essential part of their wellness operations. Here's a really interesting green roof. So this is in the middle of downtown Toronto, Canada. And we're literally talking the concrete jungle. And this is a Native Child and Family Services Center. So they provide social services to Aboriginal families, and essentially what they did is they created a roof 6 stories up that has all kinds of important elements to the native culture. So this sort of rusty round thing here is actually a sweat lodge, and I'll show you a better picture of it in the next slide. Do we have it in the next slide?
I think so, yeah.
Yeah. Sweat lodge, 6 stories up, middle of downtown Toronto. This area here is a storytelling area. Cut log seating, believe it or not, a real operating, albeit gas, fireplace, because the fire department's really close by. But then we have Three Sisters Healing Gardens, so plants, perennials, crops that are important to native medicine. And this is just essentially a 3-mound playing area, so it's all rubberized surface around there. There's even a small trickling waterfall on the roof, and all the vegetation is native to what that area had before development. So you're seeing sort of the stretching of the ideas of what a green roof is about in some of these projects. This is a Covenant House. If you're familiar with Covenant House, they have sort of inner city social organizations in many of the major cities in North America. They provide counseling, help to disadvantaged youth, street youth, try to teach them trades, try to give them things to do to make them productive citizens of society and deal with addictions, etc. So what we have here, again, this one is, I believe, 7 stories up. It's about a 7,500 square foot area that was just basically a ballasted rooftop, and they decided, hey, we want to make something of this green roof. So this area here is actually a big, I don't know if we have a different picture of it, no. It's a big open area. You can't really see it because all these planters, but these planters are in a pinwheel kind of setting. There's benches up there. It's a quiet place for people to go, receive counseling, have some quiet time on their own. But there's an added sort of element to this roof, which I thought was really cool. They decided to start growing vegetables up there. A lot of us have heard about urban agriculture and how green roofs can feed into that idea. Well, here's an organization that, because they have a teaching kitchen as part of their program, they thought, how great would it be to start off producing the vegetables from seed, having the kids help grow them, harvest them, and use them in the kitchen. So here you have your first happy guy here. He's part of that whole program, and they're now turning out kids who can turn their lives around through becoming line order cooks, etc., etc. So,
Is
Yes.
that a covenant house or is that another?
This is a covenant house.
If they're doing that program?
Pardon me?
They're doing the vegetable garden?
They are doing the program, yeah. So this here school is really quite interesting. It has a whole lot of environmentally friendly and sustainable technologies, low energy use. Dr. David Suzuki, sort of a well-known ecologist and environmentalist, put his name to this school. And there are all kinds of technologies built into the school, and naturally a green roof was one of them, but you can see pretty obvious what they're trying to say right on the front of the building with this big photovoltaic array right at the front. Well, there's geothermal, there's solar thermal, there's photovoltaic, there's daylighting. There's so many technologies in this building. And what's really interesting is you can walk through the building and they have truth windows all over the place. So you walk along the floor and also there'll be a clear plexiglass area. You can look down and see the radiant floor or radiant tubing in the floor. And you can look at the wall and see the technologies they've put in the wall. And the green roof is no exception. Here's a truth window for the green roof that shows all the layers of the green roof so you can see the technology. And what's curious about this is, if you're thinking about green roofs kind of like the Dearborn Ford plant, where it's just this big, gigantic meadow of sedum succulents, this is a complete departure from that kind of green roof. This is actually a functioning classroom. This is a grade 6 science class here, and they can come out and work with plants and get to understand basic plant biology systems. And they change out the plantings here on a regular basis. It's really quite an unusual and interesting part of their curriculum. So, those are what the designers have been doing. The designers are showing all these different ways that we can turn green roofs into something. Government has a whole different idea of what green roofs are going to be useful for. And frankly, I believe that the government and their regulation around green roof is going to be the order of the day in the future. So, what do they care about? Well, they care about combined sewer overflow and they care about urban heat island effect. Those are the two major items that governments care about. Combined sewer overflow, problem in almost every big city in North America where your storm sewers cannot handle the amount of rain that hits them at any given time. So they flood into the sanitary sewers and then you pollute your waterways.
Great Lakes.
Yep, there you go. Great Lakes, I mean, Chicago's been dealing with this for years. It's a huge problem in Chicago. Probably one of the reasons why they are one of the earliest adopters of green roofs. So the other part of it is the urban heat island effect. And I'm not sure if this, no, that's not, is that Chicago? I think it might be. Anyway, there's huge studies done on all these things. So we're trying to find technologies that will address some of these major government problems. And one of the technologies we're looking at is LID, or low impact development practices. Pavement, where water can actually percolate through rather than be all collected and redirected. We're looking at plantings, bioswales, et cetera, but we're also looking at green roofs to be a solution for this problem. This is actually a study that was done from a group in Chicago, and they analyzed 60 cities in North America, and they found that 57 of them had measurable heat island problems, meaning that the urban core was substantially hotter than the surrounding rural areas. How much hotter? Well, people are thinking maybe 2-3 degrees. Well, 15 to 27 degrees Fahrenheit. It's huge. So much so that all these cities, if you sort of just do a tabulation of all the cities looking at regulations surrounding green roofs, policies, grant programs, et cetera, there's tons of it. So, here in my sort of home area, which is Toronto, Canada, they actually had a university group do a whole assessment of all of the infrastructure in Toronto and make some assumptions about which roofs could receive a green roof, either they have enough structural load or a whole number of conditions. And naturally, they threw numbers at it. And the numbers usually are big. I mean, when we're talking about cities, we're talking about big numbers. So initial savings were pretty major. Long-term savings were billions. So the big question for me, and especially being a green roof practitioner, is if we don't pay attention to green roofs and design green roofs that are going to achieve these laudable objectives, we may be relegated to the eco chic category, where this was just a cool thing to do for a while, and in 10 years I'm going to be looking for a different job. So, or we may be seeing a paradigm shift in the way that we do buildings. So that is my intro. I'm going to turn it over to Yi, and she's going to start getting into the more technical aspects of the green roof, all the components, etc. So this is where the official AIA starts.
Hey Rick, let me just say one thing. St. Pete College is in the room, and we're doing a living building
Yeah.
with the college, and we're contributing on our side. You guys will be involved, but I don't know if you, sir, if you wanted to elaborate a little bit, but this is one of the, what, 10 or so buildings, Steve, around 12 in the world.
Yeah.
Yep, so we're gonna meet all the pedals in 2 years or whatever it is, the benchmarking, make sure they meet all the energy.
It's the Living Building Challenge.
Well, maybe we can inform some of that when we talk about all the technical aspects of the green roof that are contribute to that. Yes.
Totally naive question, because I'm new to the industry. Are we talking green roofs on buildings that could be 100 years old? Or are we talking new construction, or are you going to talk about both in your presentation?
I think we're talking about any building that could handle the green roof.
Okay.
So it's really an engineer's estimate on structural load, et cetera, but if we have the load, we have the ability to
So
put a
it
green
does
roof.
not have to be a brand new building. You could.
Not at all.
Okay, thank you.
Yeah, go ahead.
Okay, great. So I'm going to really jump into all the technical nitty-gritty of how do we produce a well-performing, high-quality green roof. So again, this is going to be really diving into the technical details of it and the objectives. Is it on? Can you hear me? Can you hear me? Yeah, okay, great. Yeah, so just diving into the technical detailing and looking at all the different component layers that go into a functional green roof. So before we start even looking at the layers, we want to look at the design parameters. Think about how we design a green roof, what's in the works here. So we have had a number of standards that have been developed specifically for green roofs, having to do with water retention, media, water retention boards, dead load, live loads. There's a number out there, and they're all associated primarily with the ASTM international standards. So these are recognized standards internationally, very standardized testing towards the materials in play. We do also have a couple of other organizations that have put out guidelines for design for green roofs, including the Fll Guidelines. So this one is actually produced from the German Landscape Association. So they're really guidelines for how to design a green roof that we've imported from the German technology in the earlier days of green roof technologies. And then I should point out also that there are FM Global standards that they've put out. So this is actually a private insurance firm that's put out their FM approvals branch. They've really, in order to be insured by FM Global, you have to pass by a set of rigorous testing standards associated with that or whatever you're putting up on there. So they're not actually associated with the ASTM, but this is required for all FM Global buildings.
It's worth pointing out that there's FM approvals. You guys probably know a lot about a lot of this, but FM approvals where they're testing actual products, and And then there's FM itself, who has put out design guidelines. If you're gonna put a green roof on our building, or a building that we're insuring, you should build it this way. So that's kind of the distinction between the two.
So once you've looked at your standards and your guidelines, there's a number of other parameters that have to go into your consideration. So Rick had mentioned the structural load. That is the number one thing you should look at before putting on a green roof. So is your roof going to be able to handle this? A lot of people talk about overloading the roof, not overloading it, but on the other hand, you should consider not underloading the roof as well. So there are ballast requirements that go into having the right amount of weight to make sure your insulation doesn't float up, wind uplift requirements, the type of roofing membrane itself. So whether it's a conventional or inverted roof is very important to your configuration as well. Any regional regulations, eco incentives that may be going into your design. And then you could think about the kind of green roof assembly that you want to put together.
You wouldn't believe how many times I've walked into a situation where someone has spent copious amounts of money on a landscape architect making an amazing green roof design, only to find out they only have like 12 pounds of load to work with, and then the whole thing's scratched. So it really is the number one consideration.
And that's for new construction and retrofits. A lot of the time, retrofits do have the amount of structural load available to put a green roof on. A lot of people think it might be too light, but it is possible. Okay.
I guess it all depends on depth and everything, but what tends to be the standard load for a standard green roof?
Wow.
If there is such one.
I don't think there is such a thing as a
there a
standard green
range?
roof. There's 3 types, and we can give you ranges for each of
Okay.
the types. But I mean, with an intensive inner courtyard type thing where you may have mature trees, you're talking hundreds and hundreds of pounds, right, per square foot.
Yeah, we could give you an idea based on the type. So there are 3 types of green roofs that are out on the market that are available. You have your lightweight built-up system. So this is primarily lightweight aggregate type media coupled with sedum succulent plantings. So like cacti or your hens and chicks, that kind of thing. You have your high performance built up, which is really everything else in terms of a green roof. So if you're thinking trees, shrubs, if you want water retention, biodiversity, that kind of thing, that's what you're looking at. And then the module kind of operates between the two. It really is targeted towards green roof in a box, easy installation. And again, these are just some of the keywords associated with each stream of green roof market. And the whole point of our presentation is to show you that regardless of which type of green roof you're going with, every single type of green roof has a fundamental requirement in terms of the functional needs. So you need every single one of these components for it to be a quality functioning green roof. Yes?
So the type of plants you use is almost immaterial, aside from the trees that you talked about. But the type of planting, like we live in we have a lot of drought or non-rainy seasons here. And I know we can irrigate it, but if we wanted to save water, we can do xeriscaping out there, right? Is that a correct assumption?
Yep, absolutely. And we also do go a little more into the type of plantings and really what's important in looking for that. So we'll start with the root barrier. So this is primarily just to prevent any root intrusion into your roof deck. And some roofing membranes do operate as a root barrier as well. So what you want to look for is that it is fully sealed throughout the entire roof. So this includes vegetation-free zones as well, because roots can find their way. And there is a common misconception about the thickness being the primary functional characteristic, but you really want to look for puncture resistance, tear resistance, elongation, and tensile strength characteristics. So for instance, this is a 10 mil versus a 40 mil, and Rick will show you a little bit of the differences between the two. but a well-made 10 mil will be a lot stronger than a single ply 40 mil. Thickness really isn't the end-all and be-all. And in terms of detailing, we want to see it throughout the entire roofing area, and then brought up actually up the parapet as well, and secured with a termination bar or taped up, all seams sealed.
All right, so I'm just going to back up because it's really important to understand why a root barrier is there. A root barrier is to keep roots out. Now that seems really basic, but I'm amazed at how many people will just lay their root barrier flat. And essentially where roots are going to cause the most issues is at flashing details, corner details, upturns, et cetera, et cetera. We need to bring that root barrier up every upturn on the roof. So one of the things that we run into in the industry is we have this mill thickness issue in the industry where people think, well, the thicker the mill, the more protection I have. But a single ply is not necessarily going to be your best bet. And I'm going to demonstrate that with these two examples. So here is a manufacturer, not ours, but a manufacturer out there who has or is specified on this project. And they require two 40 mil polyethylene root barriers taped at all the seams, which I recommend. But this two layer thing and how thick this membrane was is on a slightly sloped roof. So I went up there, see how things are going, took some pictures, and watched these poor installers trying to walk along what is essentially like a water slip and slide, you know? They're trying to walk on this thing. It's completely slick, it's stiff, so it's got no texture to it whatsoever, and they're trying to walk on it. Part of the problem with dealing with stiff products, they're really hard to upturn. So you can see what installers will do every time. If you're not there watching every detail, they'll just cut around the projection, little bit of tape, quick guys, throw the soil on before anybody sees. And this happens over and over. So essentially what we do is we're saying, hey, we prescribe performance, but we're going to try to get that performance in as thin a membrane as we can for the simple reason that it allows you to detail properly. So we use, with Tremco, we use a 10 mil, but it's a 4-ply 10 mil. It's got a reinforced polyester grid inside. So one of the reasons we do that is so that guys can come in, do the upturn, detail it beautifully like this, where we don't have any issue whatsoever. Root barrier is always capturing that whole soil zone. So wherever there is soil, roots can migrate. You need to seal up that soil like a bathtub.
So the next layer is optional. It's actually used only for conventional configuration. So it's a protection mat. And typically this is just used in order to prevent abrasive materials like aggregate or edging corners from puncturing your membrane. It's just a very thin fleece layer. It's very important actually to be aware of where in the configuration it goes. And so with a conventional system, we have it on top of the membrane, on top of the root barrier. With an inverted system, sometimes we see it used as well, but with the sealing of a membrane on top of the insulation, we see that really the importance of vapor diffusion comes into play because we don't want to seal that moisture as an impermeable layer on top of the insulation. It essentially destroys the insulation, it voids the warranty. Big thing against a lot of manufacturers for insulation. And we see this a lot with protection mat. We see it happening with moisture retention mat. A very similar type of product that other manufacturers would use. So that's another key detail that we should point out.
Yeah, so the the issue here is, you've got in a protective membrane configuration, you have your waterproofing below the insulation, right? Polystyrene on top. Well, both Owens and Dow have a requirement for vapor diffusion on the top. If you put this fleece membrane on top, well, yeah, it's porous when it's dry as a bone. When it's wet, it's impervious. So essentially, now you're driving vapor back into the insulation. Guess what? You just voided your warranty. So this is done so often in the industry, and the number of fights we get into with design professionals because we're saying, you're asking us to do something that is completely counter to the benefit of the building. And yet, because some other manufacturer has said, well, this is how we do it, it's almost like set us up to get forced into it. So it's really important to understand, we need that vapor diffusion, an air layer above that polystyrene in order to ensure that it can diffuse any vapor and not trap it in the polystyrene.
Yes, Robert?
Go ahead, sir. You go ahead.
Go ahead, you go ahead.
No, you go first.
Yeah, just to reiterate, so you can understand, you have the root barrier, then you have the vapor barrier, the moisture, this barrier on top of the root
No.
barrier. No,
No.
the other way.
No. So, let's back up here. All right. So this is a protection mat.
Okay,
Protection basically is all about protecting the roofing membrane.
the roofing membrane. Okay.
Not protecting any of the green roof
Okay.
components, just protecting the roofing membrane.
Okay.
We put it on top of the root barrier. So this dotted line here,
Okay.
that would be your membrane, your roofing
Right.
membrane.
Okay.
Okay, so with Tremco it would be something like a TPA
Yeah,
on top of your insulation. Okay, then you'd have your root barrier,
right.
and then the red line is
Okay.
basically your protection mat. And that protects you from any of these other elements that you're putting down from causing abrasions or puncturing the membrane. Okay? What we're seeing in a protected membrane configuration where the roofing membrane is underneath here, so it's right on the roof deck, then you're adding the insulation on top. People are putting these impervious membranes right on top of the insulation.
Ooh, okay.
And that will void the warranty.
Okay.
It'll basically cause vapor to drive back into the
Yeah.
polystyrene. So,
I see.
yeah.
Okay.
Again, another question, where today you're in a very warm climate, but you said you're from Toronto.
Yep.
Is the same material used in different climates, where in Toronto it could be -10 degrees, and, or is that something?
So we work all over North America. So we're used to the Southwest, the Southeast.
Yep.
We're used to all these different environments. And yes, there are regional differences, but we don't customize every product to accommodate regional differences. It's much easier to make sure that all the products accommodate regional
That was my
differences.
question, so
Yeah.
when you make a product, it's designed by
make
the
sure it works
manufacturer
everywhere.
from -20 degrees to 150.
Exactly.
Okay.
Yep. Yep. All right. You're up again. Sorry.
Okay, so the next layer is the drainage layer, and Rick had mentioned to ensure this clear air layer right above the insulation. Well, this is where it would come into play. This is one of the most critical layers of the green roof, clear drainage, and I want to make it clear that also it has no water holding capacity. We're not talking about that yet. This is just purely for drainage. So what we want to see is throughout the entire area of the green roof, and at the edges, we want to see it brought up to create a continuous air loop throughout the entire green roof area. So this prevents any intermittent hydrostatic pressure along the edges, especially in climates where there's freeze-thaw cycles. And it just actually creates a very comfortable environment for the plants and the roots to grow as well, having that continuous air layer.
So one thing that's really easy to remember is if air doesn't move, neither will water. So if you maintain this continuous loop of air from parapet to parapet, you're going to allow for free drainage underneath the growing medium.
You're also going to allow for evaporation too, which is what you want.
evaporation of any excess
Water,
moisture,
correct.
yes, under the system. Yep.
Now the next layer is for water retention specifically. So this is a combination drainage and water retention component. Panels, sheet drains, that kind of thing. And this just makes a little more moisture available to the plants. Now there's a common misconception that this is where all your water retention is. Not a chance. This is maybe a seventh of what you can actually get from a well-specced growing media. So some of the types out there, you have your sheet drain with the retention cups, drainage holes, and then you might have a panel type formation with a little more water retention capacity. What you want to actually look for, the Asdm test I mentioned, specifically it's E2398, that's going to give you the numbers for water retention. So a lot of manufacturers out there, they'll say, we could hold this much water. Where are the test results for that? Another thing is there's a lot of different types of products that might look similar, but what you want to look for is retention cups at the bottom, holding your water, drainage holes at the top, so any excess water can drain out. And compressive strength, there's a lot of recycled material type products out there as well. But really, the retention cups and the drainage holes functioning together so that you have a functional drainage panel. That's key.
So on the compression strength, I find this interesting is I see out there in the market somebody who's got a panel that's got 10,000 pounds per square foot, and the next guy's got 20, and then of course someone else has to up it to 30. None of those are even practical considerations. You're probably not ever going to see a compressive strength requirement more than 8,000 pounds. So it's only in highly specialized circumstances that you need those sort of things. But as some manufacturers tend to do, it's always a matter of setting some different bar, even if it has no practical implication.
And then really quickly in terms of the detailing of it. So if you have a panel formation, this is going to go right on top of, and this is for an inverted membrane, by the way. So your panel is going to sit right on top of your insulation. And this will actually provide the air layer as well for your, right on top of the insulation. Goes right up to the parapet. For a sheet drain type, you're actually going to wrap it up again in the same way that the drainage layer does, just once again to create that continuous air loop. Now the next layer is extremely important once again. This is your filter fabric and it contains your growing media within the green roof area. Contains it where you want it, keeps it out of where you don't. And this is one of the most common sources of failure we see in green roofs, not properly detailing your filter fabric. So what we want to see is that is completely sealed, and to note that there's no filter fabric out there that's UV resistant, so it should always be covered, yeah, basically, by soil or by edging, just cover it. Yes?
A couple of days exposure, is that okay, or is it like 0 days exposure?
Yeah, that's fine.
No, I mean, honestly, it would probably sit out there for 6 months. It would degrade slightly, but we're talking about long-term exposure. So if edges are exposed long-term, you'll see them start to deteriorate and flake apart.
Right.
So, yeah.
Now, in terms of the detailing, this is one of the most important details that you should look out for. So with our filter fabric, we want it fully seamed with tape, just so that there are no holes in between the different layers. And then at the very edge here, and this goes for any vertical surfaces, we want it to be brought all the way up along your drainage layer, and then sealed 1 inch above the soil level. So basically it's just contained like a bathtub with all your growing media in this filter fabric area. And
All right, so.
when it doesn't happen.
So here's, you know, it's just unbelievable how many times we see in the industry this simple detail done so poorly. And I'll give you a snapshot on how bad this can get. So I was asked to look at this project because the entire roof was super saturated. All that was growing up there was algae. And they were blaming it on the growing media. They said there's something wrong with this growing media. It must have been toxic, or it holds way too much water or something. So I thought, well, okay, I'll have a look at it. So I came up there, and sure enough, I saw a filter fabric that was just laid up against a concrete curb. Wasn't sealed, nothing. Eventually it deteriorated as well. But you can see me, I'm pulling this up, and that green stuff right below my thumb is under the filter fabric. Essentially what had happened to this roof is because they didn't detail the filter fabric properly, all this media eroded down into the drainage area, completely clogged it up. They had covered all the roof drains up, so we didn't even know where they were. We had to go find the shop drawings from the original installation, and they covered them up. Essentially the entire roof could not drain. So it was just building up, building up, building up. And what was happening is the water would build up, and the only way it could escape was to spill over the curb into the patio area and find a way out there. Cost to the owner about $250,000. So that was on top of the 180 that they put in to putting it there in the first place. So one of the reasons why it's such an issue is because once growing media has gone sour like that, it's impossible to remediate. There's just no way we can't add, you know, any sort of amendment that's going to restore that soil anymore. It's literally got to be taken off the roof.
So now we're going to talk about the two most important components, the vegetation and the growing media. Now, it really is about choosing the right growing media with the right vegetation for your uses. And we'll go through a couple of different types of green roofs. So, really beautiful, blooming, colorful green roof. This is a sedum succulent meadow. This is a different type of green roof. So it's a mix of the sedum succulents that we saw earlier and then some wildflowers. And then we have a beautiful wildflower meadow. Now, all three of them are aesthetically pleasing. They could offer a number of benefits to the end user. But when we're talking about growing media and we're talking about vegetation, here's also where we're talking about performance of the green roof in the ways that matter. So water retention and then urban heat island effect, so cooling. When we look at the metrics of it, the first green roof, while beautiful, holds 0.2 gallons per square foot. The second, a little more, about one gallon or so. And then the last one, this beautiful meadow, 3 times as much as the previous roof. So when you're thinking about what you're putting into your green roof in terms of media and vegetation, what you're getting out of it is going to be very different. And those are really the results that we've seen time and time again from years of experience. But there's been groundbreaking research coming out of the University of Toronto, the GRIT lab over there, Green Roof Innovation Testing Laboratory. And this is the first instance of empirical data that actually shows what we've had a hunch about for over a decade now. So this won the ASLA Award of Excellence in 2013, and it's really the first instance of rigorous, comprehensive research for green roof technologies. So there's about 33 test plots with different combinations of growing media, vegetation, irrigation regimes, and what they found overwhelmingly was the urban meadow we showed you earlier holds 3 times as much water as the next green roof. It's not even no green roof, it's the next green roof. And that it offers conservative 30 degrees Fahrenheit cooler than the next green roof. So these are real performance metrics that you could put into your cost-benefit analysis for putting a green roof in.
So just to interrupt, how are we doing on time? I think we're gonna run over, aren't we? Okay, all right. So
Okay.
I do want to add a point here, because if you come out of this room with anything, this is probably the most important area. I've been all over the world. I've been asked to speak in different countries. I've done research on the German FLL standards, and it's always been curious to me why this prescription of a high aggregate media combined with a very low cooling benefit plant has become the de facto green roof standard across the world. And if you look back to why the Germans did it, and they're the ones really who got this whole standardization going like they do with many things, right? The terms of reference are really important to consider. Their terms of reference were heavily biased because of some colossal failures that happened in their market, highly public failures, where people were just throwing stuff on roofs without a whole lot of research, and they were having roofs collapse, they were having drainage systems compromised, et cetera, et cetera. So their terms of reference were, what kind of green roof can we put up there that will cause the least issues? So in other words, we need a fast draining growth media, so that there's no chance we'll get a saturated flooding condition. And then once you go there, you really can only look at plants that can survive in those circumstances. Move to North America. Why do we want green roofs? We want to hold stormwater, we want cool environments. Well, the prescription from Germany does neither very well. So it's like two completely different ideas of what a green roof can offer. In Germany, they were just trying to find the lowest common denominator. And here, we're really trying to find performance. And governments want to see green roofs hold water. They want it to be done safely, naturally, and they want to see cooling. Well, in both instances, these things imported from Germany have sort of flooded into our market, but they're really not offering what our market wants. Yes.
I have a comment. I'm not like a specialist on that, but I know like you're talking about the Germany and the other country thing. I'm not sure, but the researchers I'm pretty sure are doing that. If you start selecting something called a C4 group of plant, there are two major group of plant, like your C3 and C4 group of plant.
Yeah.
So the benefit of the C4 group of plant is going to be lighter first, then it is not going to take care of your moisture issue or media water retention thing, but it can also be very beneficial in the greenhouse gas recycling, because C4 plants are like, very good at like recycling the carbon monoxide, carbon dioxide, etc. And that would be like, the another thing you can bring, the whole another gamut, like,
Well, the whole area of C4 and C3 plants. So C4, the plants you're seeing, the sedum we keep talking about, they're like a subsection of C4 plants called crussellation acid metabolism plants. I won't go into a ton of detail.
Yeah.
But what makes them really special in terms of survival is they split up photosynthesis into two stages. So they can actually, and this has the result of actually holding moisture in the body of the plant during the heat of the day and releasing it when it's cooler, making them very good at drought resistance, but the exact opposite for cooling a building. So they'll cool it in terms of shading, things like that, but they're not releasing transpiration into the atmosphere, and that's where we get our cooling benefit. So you really have a decision to make. Do you want my green roof to survive? And it provides a lot of different benefits, but if stormwater and cooling are your number one things, that may not be the best prescription.
Yeah, I mean, one doesn't fit in all the need. You have to go with the environmental situation, and then you have to select your plant and the media.
Yep.
I had a question. It looks like the examples you're showing, they're completely covered. They don't look like roofs that people then are out walking on and sitting out in. So I guess I have to assume if the less covering you put, ground cover, the less effect you're going to have as far as the cooling end of it. If you're going to make paths or seating areas or?
There, we actually have examples of all of that.
Okay.
Yeah. So we do have to keep rolling.
Yeah.
here, though, so.
Okay, so just a little bit more into the medias that Rick had mentioned. So the two types that you'll find out there, really a organic dominant blend and an inorganic dominant blend, but both will actually have both organic components and inorganic components. It's really about the balance between the two. And I just wanted to show you really quickly how you actually calculate for that water retention between the two. So this is the Asdm testing that I had mentioned before, the 2399. And right here in the test, what you want to look for is the bulk density at maximum water holding capacity that's fully saturated. And then the dry weight, so that's when it's just been basically oven baked. So
to clarify, it's fully saturated after free drainage. So in other words, it's a real holding capacity.
Yeah. So the difference is the maximum amount of water that your media can hold. It's basically water. And with organic media, we have something around the neighborhood of 5.5 to 6 gallons per cubic foot.
Is that weight for us to calculate the volume of water, or is that weight for us to know what the load imposed on the structure is?
Both.
Both.
Both
Yeah.
are the same.
Yes. Well, you're looking at your maximum load, and because a flooded condition on a roof, you already calculate, right? So you're looking at your maximum load that the green roof is going to add, and that will be that second number, the 68 pounds a square or a cubic foot.
Plus whatever vegetation weight, water retention panel weight. Yeah, but that's around there. Now, if you're looking at a high aggregate media, look at the difference. So here we have 68 at maximum water holding capacity. For aggregate, it's not actually a lot more, 78, but then the dry weight is actually quite a lot more. So the weight is really in the aggregate, the rocks that are part of this mix. And then what you're getting in terms of water retention capacity is a lot less. So as much as half of that. And then the next number you want to look for is the water permeability. So this is really the percolation rate. If your media is completely saturated, how fast is more water going to drain through if you have another storm hit? Now, for our organic media, we're looking at about 24 inches per hour. That's enough to handle any kind of drastic storm that we have here in North America. If you're looking at an aggregate mix, it's actually going to be a lot more. So 40 inches per hour, whatever water that you're able to contain, it's actually already draining right through the media. So this is where your water retention capacity is really as low as it can be in terms of a lightweight aggregate media. And also in terms of the logistics of installation, so you could either do it in super sacks, thinking about point source loading up on your roof. It's a whole other logistical nightmare, really. A lesser known method is blowing it up. So it's hooked up to a blower truck, all the media goes through a hose, and then you could just level it off as you install it. And then really quickly about the vegetation as well. So we talked a lot about choosing the right kind of vegetation for the right kind of media. With something like a lightweight aggregate media, really only the things that are drought tolerant are going to survive. Whereas if you want anything else, you got to give it more nutrients, more moisture, make it available so that they can really use it. I wanted to show you really quickly the type of vegetation you have out there. So this is a cuttings green roof. So it's sedum cuttings. You could actually take any part of the sedum, put it on a little bit of dirt, and it will grow. So this, we spread it. It's very cost effective in this manner. You just have to make sure that it's a good growing condition, so we have erosion control netting. And after 2 seasons, you could have a full green roof as well, but it takes a little more time.
Well, that's the second season.
Yeah, the second season, sorry. Yeah, another option for sedum is going with a plug planting. So this is actually, it's got a little bit of a root ball at the end as well. But in terms of creating coverage for a green roof, this is actually a lot more difficult because you'll have to fill it in a lot more or wait quite a while before the plugs are fully mature. Yes?
What's the horizontal grayish looking things going across the page?
These?
That's just a design feature.
Yeah.
Just put these concrete curves along to separate. There's actually some blue festuca in
So it
there,
has no
so it's
function
really
to
just a
the roof.
design
Okay.
feature. Yeah.
Yeah. Another option for sedum is if you have mat or a carpet. So this is really a lot like sod. You roll it out, and then it'll be ready to go, pre-vegetated. And this is actually just a couple of weeks after installation. So this is probably your easiest way to go if you're going with sedum, but it's also probably the most costly option. Now you also have your standard kind of planting, so trees, just like you would on the ground for an intensive application, tree shrubs. And this is the lesser known option in terms of creating a meadow. So here we have the terrace seeding and blower truck combination. So I talked about having a blower truck blow in all the media at the right grade. With a terrace seeding, you could actually inject the seed into the blower truck and then blow in the top 2 inches of that with the seed already mixed in. So if we
Hydro seeding is still a separate process, but this actually takes dry seed, runs it through an injector in the truck that injects it into the flow of this growing media as it goes out. So it's a one-step process.
exactly.
Yeah.
So just take a note at the date in the corner there, June 23rd. This is just a few weeks later, and you could already see a little bit of green popping up. This is another week later. Some of the species differentiated already. And this is August, you know, and you already have a fully covered roof. And then by the end of the season,
1 month, 10 days.
yeah, you have a beautiful meadow already up there, all the species coming up, some of the species already flowering. So it's a really good, cost-effective option to getting a full green roof. And then we'll talk very quickly about modules. So this is another segment of the market that's available out there, and it's really a pre-vegetated unit with multiple components integrated already into one. So here, for example, we have some drainage, growing media, vegetation all together. And what you want to look for is positively locking clips. You want a permeable sidewall, so roots and moisture can migrate between modules, and clear drainage.
All right, so honestly, I wish the modulars never entered the market, but they have. So we got to talk about them, and we got to deal with them. Frankly, all the components of a green roof have to remain the same, whether it's in a module or not. You still need free drainage, you still need some sort of filtering mechanism so growth media will not erode through the system into the drainage area. You need all these things. So one of the things that I see quite often, here's one of the leading trays in the industry, and they don't lock together. So they don't fit together, they just slide together. So all you need is a worker to come along, step on a corner, pushes the tray sort of off a bit. Well, you can see here, about 1.5 inches exposed. Well, what does that tell you on the other side of that tray? It's a fixed 24-inch tray, so that means we've got a gap somewhere. So that's why we say it has to positively lock together. You need to hold these trays tight together so that there's no opportunity for media to erode down through the modules. So that's one of the things. The other part of it, here's a tray out in the marketplace, solid sidewalls. So as a horticulturist, that's a flag for me because I'm thinking, well, the whole idea is to allow the plants to thrive and flourish. Well, this is like putting a whole pile of pots on a roof. So you're limiting your plant's ability to find resources for it to be healthy. So what you get often with these types of systems is almost like a checkerboard kind of pattern of plants where you have some plants doing well, others not doing so well. There's no sort of cohesive environment for them to share. The issue with this one gets worse because it's slightly slanted and it has this recessed section where now you've introduced an air gap between the trays. So there's absolutely no chance anything is ever going to bridge that gap. Very few roots will grow through air. Last thing, again, one of the leading manufacturers, they almost brag about this, that they don't need filter fabric. Well, I beg to differ because when I looked at this award-winning project, I looked underneath the trays and there's all the media. It had gone into the drainage zone on top of the membrane and it had started to clog up the drainage course. So all those things that we showed you in all the layered systems, they have to be there in the modular as well. So, all right.
I think the coconut ones we used to have degraded into the plants, killed the plants on the roof.
Yes.
Is that what happened?
That was before my time. I caution you against it, just for the record.
I'll go with the coconut. Yeah.
All right,
Okay.
so we're going to wrap this up quickly. I'm going to take it from here. So, edging. A couple things to look for in edging. Solid top, drainage at the bottom. We don't want, plants are no respecters of some of the boundaries that we give them. So this is the kind of boundary we want. We want edging. We want a nice, clean, vegetation-free zone. It's supposed to be vegetation-free, right? Where does it happen? It has to encapsulate the media in all the plants. Usually the weight of the system is what holds it in place. Vegetation-free zones are very much meant to be vegetation-free zones. The use of aggregate in vegetation-free zones is really a problem, especially with sedum, because that's an environment they are very functional in. So you get sedum growing in, you get a little bit of refuse sort of collecting in corners, and guess what? Sedum's found a happy home, and now they're clogging up your vegetation-free zone. Here's an example of why edging needs to be solid up in that growing area. Plants are no respecters of those boundaries. They're going to grow wherever they find a home. Drain treatments, again, one of the huge areas of poor treatment in the industry. This is what we want. We want to isolate that drain from the interference of the vegetation and media, simply because we have to maintain drainage. It also gives you an opportunity to lift a lid and see how a drain is functioning. Without it, you could have all kinds of problems. The way we detail it, we bring filter fabric up and over. The drain holes are down at the drainage level. Everything's nice and sealed. Here's some examples of how not to do a drain. That's a roof drain. I don't know if you see, but that's got black-eyed Susans germinating on top of it. So that's not a very effective roof drain. Here's another roof drain, also with plants growing inside that screen. And then the vegetation-free zone, which is quickly becoming compromised. Here's a great example. Again, award-winning green roof that I went and visited. So this was in the fall. You can see everything's kind of dormant. But you can see the sedum already encroaching in that area. That's the following spring. Exact same drain. Now the sedum has almost completely covered the aggregate. In no time at all, it's going to cover that drain. Yes?
Do you still pitch your roofs the way you normally would? Or do you put, like for roof drains, normally you pitch them to low points? So
There should always be positive slope to drain. Yeah.
Okay.
Having said that, the size of the drainage component can sometimes help take some of the vagaries away from not having enough slope. That's it. Sorry, Yi, but I had to like press the accelerator. Yes. Yes.
This is a really basic question, but are any of the vegetated roof systems approved for use in Pinellas County? We have to have water product approval or Miami-Dade for the roof assembly. So I
Yes,
don't even know
and
if
here's
it's
part of the
acceptable.
problem. I'm saying yes in a very cautious way because certain testing methodologies are not available yet. So we have to use sort of old ways of assessing the green roof. For example, you need a certain ballast to resist wind uplift in Miami-Dade regulations, right? So the green roof becomes that ballast. There are regulations being worked on right now, but they're not complete. So we can't point to them until they're done, so, yeah.
Go ahead.
So I was gonna say, the
Another
code
question.
allows for, if you don't have product approval, you don't have Miami-Dade, you're allowed to use an independent engineering firm, structural
Exactly.
engineering firm, I think that's 9SR or whatever it is.
Yeah,
that
so we don't have
FAR
any
statute.
sort of clear path to it. It has to be an individual assessment for each roof. Having said that, we did one in West Palm Beach not that long ago. Beautiful green roof. Plants are looking fantastic, all locally sourced, so, yep.
Can you go back to the detail with that metal deck? Was that,
Metal deck.
if you go back, there was,
Corrugated.
you see a corrugated panel or whatever that, what is
Yeah,
that
there is.
made out of?
Oh, that's actually the drainage component. That's a plastic green roof
Oh,
drainage
Plastic?
component.
Okay,
Yeah.
'cause,
yeah.
yeah. looks like
I know, it looks a
it's
bit like a
yeah.
corrugated.
Yeah, it does.
Yeah, yeah.
Sorry, yeah.
As an owner, how do other owners address the warranties of the, perhaps the existing membrane roofs? Will this require like a re-roof in order to have a warranty?
Billy, why don't I let you, or one of your friends here answer that one?
The question is, does it require a re-roof?
Right, because I'm thinking my existing, say, 15-year or 20-year warranties are going to be voided by this process. Would I then do a re-roof in order to have a warranty?
Right, well, the substrate itself, in terms of roofing, we're gonna need to take a look at your existing roof for sure. There's some candidates out there where we may accept it in terms of a warranty. But we'd have to come out and do a detailed inspection. I know there's been some cases where a roof may have been put on within a year or a year and a half to 2 years.
Right.
We'll take a look at it, there's some diagnostics that have to be done, infrared scanning, core cuts, if it's multiple plies, to check tensile strength, that type of thing. But I would not rule it out with something 15, 16, 18 years old, and then you're gonna put a warranty and put a green roof on top of that, and then expect us to warranty, most likely would not happen, and then probably have to each one on.
So I think, the short answer is, yes, Tremco will warranty a roofing system, but it's dependent on it meeting a
Yes.
whole bunch of criteria.
There's some criteria, there's some diagnostics. We need to look, we need to look at your existing roof.
Like West Palm Beach was actually a great example.